So today we're looking at the observable properties of a rock. By looking at these observable properties, the first one I'm going to look at is the size of the rock. So it's smaller than my hand. So I'm going to record that it is small. And that's just a generic term. Next, I'm actually going to do some measurements. So I want to use what I see. I see it as small, but now I'm also going to do some measurement. I'm going to use a ruler to measure the rock. And by lining it up carefully on this pad that I've got with some grid squares, I'm using the centimeter side of the ruler. We always use metric measurements in science. Just all scientists throughout the world use the metric system. So by looking at this and lining up the edge of the ruler on this line and the edge of the rock here, I can see, and I'm going to use my pencil, I'll just place my pencil right there. This rock is, I'm going to go to the nearest half centimeter, 6.5 centimeters, or 6.5 centimeters, and I'll record that. So now we'll record this measurement, and same thing, I'm placing it on this line, and I'm measuring it. I'm looking carefully to see. So when I measure the rock in this dimension, this is 7.5 centimeters, 6.5 by 7.5, and then we can measure the height. And here I'm just going to kind of get down even. I want to get down, get my eyes level with the rock so that I'm looking straight across, not down from above. I want to look straight across, and this rock is about 4 centimeters tall. So we described the rock as being small, and then we measured it, and the measurements are 6.5 centimeters by 7.5 centimeters by 4 centimeters. What shape is the rock? I would say the rock is very irregular. It is very irregular. It looks a little bit, it's a little bit like a flat ball shape, so I'm going to describe it as a flat ball, and very irregular. In other words, it's not a prism, it's not a sphere, it's not a cone. It is very irregular. Record that data. Now I'm looking at the color of the rock, and looking at the colors, I can see highlights of whites. I see lots of kind of browns and tans. There's some grays in there, a little bit of yellow, and I'm just going to record those colors: whites, gray, brown, and tan for my colors. The temperature of the rock. If I hold it in my hand, it doesn't feel warm, it doesn't feel necessarily very cool. It feels cooler than it feels warm. So I'm going to write down an observation that that rock feels cool, but then I'm going to use, again, when we use our senses, I also want to be able to measure that. This is an infrared thermometer that, without touching the rock, can measure the temperature of that rock. So I'm going to step over here for just a second. When I press the button, there's a red dot. See that red dot right there? It's measuring the temperature of that surface. So for my green pad, it's telling us that the temperature of the green pad is 83 degrees Fahrenheit. I want to go in and I want to change that to Celsius because, again, we use metric measurements in science. So I changed it to Celsius. I'm going to retake that temperature, 29 degrees Celsius, and now I can take the actual temperature of the rock itself by pointing the thermometer there. Now it's still showing the last temperature that I took. So I'm going to point the thermometer. The light is shining on the rock, and the thermometer is telling me that the rock is 29, 28.9, 28.8. It's off. We're going to round up to the nearest hole. We're going to say it's 28 degrees Celsius. Cool, 28 degrees Celsius. And I'm going to put a C there so that I'm sure that we know that these are metric measurements and not standard measurements. Next, we're going to look at weight and mass. Weight and mass mean about the same thing in elementary school. When you move into middle school in 8th grade, you're going to see that they're actually slightly different, so I don't want to confuse you. They mean about the same thing. How much does the rock actually weigh? Now, there's a couple of different ways that I could do this. I could hold it in my hand and I could say that it's not heavy. Okay, not heavy. That is an opinion. Now I want to get an actual observation, and I'm going to use this digital scale, turn that on, and what's the first thing that I want to check for on the digital scale? I want to make sure that it's set to grams, the metric unit for weight or mass in science. So I'm on grams, that's good. The scale is showing me 0.00 grams, which is good because there's nothing on the scale. Now I can place the rock on the scale, let it come to a rest. Again, I'm going to round to the nearest hole, 174 grams, and record that measurement with the abbreviation for the unit of measure, which is grams. 174 grams. Now I can turn that scale off and set that to the side. I could also use a spring scale. Spring scales have the unit of measure on the side. You'll see over here on the side, here's grams. The other side of this scale, it's very faint, you probably can't see it, but there's an N there. We use that during force and motion to measure the amount of force that something has. To use a spring scale, if you've ever been fishing, you use these all the time. I simply take the rock, and I'm lucky with this one because this one has a nice hole in it. See that hole right through there? So I'm just going to take that hole in the rock, hang it from there, and this rock is not even measuring on this spring scale. And the reason for that, we know that the mass of the rock, we already recorded, is 174 grams. This spring scale measures in units. See that? 500 grams. So that rock at 174 grams hardly moved that spring scale. I would want to use a different spring scale. I only have the one. I would want to use a different one to measure the mass of the rock. Little pieces are falling off here. Use my brush to clean that up. Next, we're going to talk about texture. I already noticed that hole in it. So texture is how it feels to the hand. There's no sharp edges. There's no smooth edges. Texture is very rough. Very rough. I'm going to record that with many holes. And I don't just mean that one hole that's in the center of the rock. There are other holes that are, there's a hole right there, here's one. There's lots of holes on this rock. Also, as I look closely at the rock, I'm noticing that there are things like shell shapes in here. Let's see if I can find a good one to describe to you. Here's some pieces of shell. So I might want to write that down in my observation that there, and I'm going to include that under texture, pieces of shell. Pieces of shell, and they keep falling off, sand, pieces of shell, and sand. So this rock is breaking apart fairly easy. Now, the next one on my list is sink or float, whether or not the object sinks or float. I'm going to save that for later. I'm going to come back to that because we're going to put the rock in the water to see if it sinks or float, but we're going to do one more measurement using that. Next one is magnetic attraction. So here's a magnet, and I know that it's a magnet because I've tested it. I can see that it attracts this nail pretty quickly. Now I'm going to use my magnet to see if it is attracted to this rock at all. Does the rock pick the magnet up? Is the rock attracted to the magnet? and it is not. Magnetic attraction, we're going to record no. Another way that I can test magnetic attraction is with a compass. This compass right here is set to north. You'll see that the needle will always point north. Depending on how I'm holding my compass, I can either spin the dial so that the N sits where the arrow is, or I can turn the entire compass until N matches the needle. To determine whether, and how I can use a compass to figure out if something is has magnetic attraction, is I bring the compass close to the object, or I can wave the object over the compass. If the compass needle moves when it's near the object has magnetic attraction. Move that away, here's a magnet. And you can see from very far away that my magnet, which is a very strong magnet, is attracting that needle and moving that needle without moving it, or without touching it. So magnetic attraction is a no. Odor, I have a bad sniffer. I don't smell well on a good day, and no, I don't smell. It has no odor. Taste. I am not going to taste a rock. We would very rarely ever use taste in elementary school in our observations, so I'm just going to draw a line through taste. Your teachers can do things with you for taste. Foods are good. Known foods are good. Be careful of allergies and those kinds of things. So it has no odor. I'm not going to taste it. The last thing I'm going to do is sink or float and volume. And the way that I'm going to do that is I've got two containers here. I added some food coloring to the water to show that make the water a little easier to see on camera. So I'm going to take my object now, and I'm going to use my tongs, and I'm going to place the object into the container of water to see if it sinks or floats. Does the object sink or float? The object sinks. The object sinks. Now I'm going to measure volume. Now with a rectangular prism, it's very easy. I would take these three dimensions at the top. If this was a rectangular prism, I would multiply length times width times height, 6.5 times 7.5 times 4. But this is not a rectangular prism. This is a very irregularly shaped object. So what I'm going to do is pour the water into this container, and you'll see that this container is marked in milliliters. That is the metric unit of measurement for water. And I'm going to pour this so that when I place the rock inside, I don't want too much water, and you'll see why in a moment. I'm going to place the rock inside, and I don't want the rock to stick up out of the water. So I'm going to put, let's see, I'm going to put 300 milliliters of water. I'm going to pour 300 milliliters of water, and I'm pouring that until it comes up to that 300 milliliter of water line. Okay, looks good. I'm going to double check it, make sure it's a little too much, so I'm going to return some to this container. Check it again. Still a little much. That's good. That's good. We're really close there. So 300 milliliters. Right now there are 300 milliliters of water in the container. To measure volume, I'm going to put the starting volume of water, 300 milliliters, record that. Now I'm going to add the object. This is an irregularly shaped object. I'm going to add that carefully to the water. Get my tongs back out. I probably should have picked a different direction for that. Okay, let's grasp it that way. Now, go there. And you'll see that when I put the rock into the water, the level of water came up. Let's do that again. Okay, it's at 300. I add the rock, and the water comes up. Now, if this is 400 milliliters here, it's not quite at 400 milliliters. It's not quite at 350. I'm gonna use some, I'm just gonna round, and I'm going to say that that's about 360 milliliters in volume. 360 milliliters in volume. Does that mean that the rock has a volume of 360 milliliters? No, I have to do one more thing. I have to take the rock out. The water level returns to 300 milliliters. What I need to do here is just a tiny bit of math. How much water did I start with? 300 milliliters. The water rose to 360, so when I subtract the amount of water that I started with from the amount of water that the rock lifted it to, that gives me 60. The volume of the rock is 60 milliliters, approximately. So I've gone through now and I've done all of the observable properties on just this one rock. I did size, shape, color, texture, temperature, weight, mass, texture, sink float, magnetic attraction, odor, crossed out taste, because I'm not going to taste a rock, and I found the actual volume of the rock using water displacement. We call that method water displacement. So those are observable properties. Thank you very much.